Now that we have been introduced to logarithm in general, let's define natural logarithm. The natural logarithm of a number is the logarithm base the constant e. E is a constant equals to 2.7182 and so on. Now when the base is e, we do not write log x base e. Instead, we use the symbol len x. Len x stands for natural logarithm. Its domain of definition is positive numbers, x belongs to 0 plus infinity, and also it can be seen as the antiderivative of 1 over x. Now, len x is the antiderivative of 1 over x defined over 0 plus infinity. The logarithm satisfied the condition len 1 is 0. It passes through the point 1, 0, as you can see in the graph of logarithm. We will study it later in detailed way throughout the lesson. Properties of natural logarithm. Now that we know what len x means, let's see more of its useful properties. For all positive values of x and y, we have mentioned that len x is defined for positive values of x. We have len xy is len absolute x plus len absolute y. So, for example, if you have len 2 times 3, you can write it as len 2 plus len 3. When we multiply the numbers inside the log, it turns into addition outside. Len x over y is len absolute x minus len absolute y. Remember, the value for len should be positive. That's why we use absolute value. Division inside the log becomes subtraction outside it. So dividing numbers turns into difference of logs. Len 10 minus len 5, for example, can be written as len 10 over 5, which is equal to len 2. One more property, len x power y is equal to y len x. When we have a power, we can bring the exponent down in front. This is so useful in solving equations with exponent. Example for this, len x power 2 can be written as 2 len x. Now let's solve the following equation. Let's find x using the properties we have learned. Len 2, our goal here is to make both sides len equals len. Then we remove len. Len 2 plus 2 len x, we will write it as len x power 2 because of the property len x power y is y len x. So here 2 len x can be written as len x power 2. So len 2 plus len x power 2 is equal to len 7x minus 3. Now len 2 plus len x power 2 can be written as len 2x squared. It's equal to len 7x minus 3. Why we can write this? 1, because len x plus len y is equal to len x y. Now as len equal len, we can remove len. 2x squared is equal to 7x minus 3. So 2x squared minus 7x plus 3 is equal to 0. This can be factorized as 2x minus 1, x minus 3 equals to 0. So 2x minus 1 is 0, or x minus 3 is 0. X is half. This is accepted. Always when we have condition for x, you have to write accepted or rejected, or x equals 3 accepted. Both values are accepted since they are positive. The last property of natural logarithm is that len e power x is equal to x. Why is this? Since len means log x base e, log x base e, asking for len e power x is like asking what power of e gives me ex, the answer is simply x. So what power of e gives me ex? It is simply x. And e power ln x is equal to x. In other means, e and ln cancel each other. So ln ex is x, e ln x is also x. They are opposite operations, just like square and square root. They cancel each other. Now finally, ln 1 equals to 0. Why is this? Because e to the power 0 is 1. So what power of e gives me 1? It is 0. Now, ln e is 1. Why? What power of e gives me e? It is simply 1. These rules are the foundations for simplifying, solving, and understanding exponential equations. You will use them a lot, so try to remember them as logarithm toolbox.